Sets and Venn diagrams. Some word problems concern sets and members of sets. So I'll just say that the topic of sets overall is potentially complicated because human beings can belong to several sets at once. Any one human being is a certain gender, they have a certain native language, a certain socioeconomic class, they have a favorite flavor of ice cream, etc., etc. There are hundreds of ways to classify human beings. It's a very complicated topic. Fortunately, the test focuses on a few relatively simple scenarios. The first set scenario, the easiest, is one in which there are two groups, and each member of the collection may belong to either group individually, or to both groups at once, or to neither. For example, at a high school, the two groups might be on the baseball team and in the band. Obviously, some students will be on the baseball team. Others will be on the band. There'll be a few talented students who are on both the baseball team and in the band, and of course there'll always be some who are not participating in either. This scenario is often represented by a Venn diagram. A basic Venn diagram consists of two overlapping circles inside a rectangle. Occasionally the test will give this diagram as part of the question. If not, students often find it helpful to sketch one for their calculations. Elements inside one circle are in one of the groups, and elements in the overlap region are in both groups. Notice that this diagram consists of four distinct regions. So the red region, A, this is inside the left circle but not inside the right circle. So these are all the people in the green circle, inside the green circle but outside of the purple circle. So they're in the green circle only, not in the purple circle. B is the overlap group. They're in both circles. C, these are all the people in the right circle, not inside the left circle. So these are in the purple circle only, and not in the green circle. And then D are all the people outside of both circles. So notice that these four regions, when we add them up, this adds up to the total, either the total number of students or the total number of people that are in this particular study. Notice that the way information is given here, the verbal information, can be very tricky. Let's say, for the sake of argument, that the left circle means in the band and the right circle means on the baseball team. If the question says 35 students are in the band, well, that means A plus B equals 35. Because when we say 35 are in the band, we're counting all the band members. Some of the band members are in the band only. Other band members happen also to be on the baseball team, but they're all in the band. And so both of them are counted together as included when we say 35 are in the band. But if we change the wording slightly, we say 35 students are in the band only. Well, this means that A equals 35. Now we're talking about the students that are not included in the purple circle. They're only in the green circle. And so that's region A alone. So it's very important to be extremely careful when you read the wording of these questions, because subtle changes in the wording can mean profound mathematical consequences. A typical sets question of this variety almost always gives the size of the whole group, which would equal the sum of these four regions. The other information will provide some other regions, and from addition or subtraction, we can determine the rest. Here's a simple practice question. Pause the video and then we'll talk about this. Okay, so we'll start out by drawing a Venn diagram, and the green circle on the left, that's going to represent the band. The purple circle on the right, that's going to represent the baseball team. We know that 60 are in the band, so that's A plus B equals 60. 35 are on the baseball team. That's B plus C equals 35. Notice that the B's are counted twice. They're counted once for their band membership, once for their baseball membership. 25, that's the region outside. Well, that's interesting. So if outside the circle there are 25, and there are 100 students altogether, it means that all the people inside the two circles that must add up to 75, because 75 plus 25 equals 100. And so it means that A plus B plus C has to equal 75. Well, it's interesting because B plus C by itself, we see at the top, that's 35. So we can replace B plus C with 35. And that allows us to solve for A equals 40. Now we can plug that into the first equation. A plus B equals 60. So 40 plus B equals 60, and B equals 20. And that's our answer. Notice, incidentally, if you're curious, A equals 40, B equals 20, C equals 15, D equals 25, and those together add up to 100. But our answer here is B equals 20. Here's a slightly more complicated problem. Pause the video and then we'll talk about this. Okay, so French and Spanish. Let the left circle equal French and the right circle equal Spanish. And what I'll say here, unfortunately I need a lot of work to work out the algebra on this problem, so I had to go to a slide that didn't have the text of the question on it. But if you look under this video, you should see the text of the question printed, and so you can refer to that as I'm talking about this if you want to read along with me. So the first thing it says is just as many study neither as study both. Well, the both region is B, the neither region is D, so B equals D. Okay, that's important. Second, we're told 1/4 of those who study Spanish also study French. Well, those who study Spanish, that's B plus C. So 1/4 of B plus C equals the ones who also study French. So those are the people in the overlap group. So 1/4 B plus C equals B. I'm just going to clear the fractions by multiplying that equation by 4. And then it turns out I can subtract B from both sides, and I get C equals 3B. And at this point, this gives me a bit of insight. This suggests a method of solution now. Because we're able to express D in terms of B, now we can express C in terms of B. If we could also express A in terms of B, then we could solve for the value of B, and that would allow us to solve for everything. Okay, so let's think about A. The final sentence is that the total number who study French is 10 fewer than those who study Spanish only. So the total number who study French, A plus B, is 10 fewer than Spanish only. Spanish only is C. So A plus B equals C minus 10. So now we're just going to plug in C equals 3B and subtract B from both sides. So A equals 2B minus 10. So now we've expressed A, C, and D all in terms of B. This is important because we know A plus B plus C plus D equals 200. And we can substitute those other letters for expressions involving B. And so we'll just add 10 to both sides. So we'll get 210 on the left. And then we get 2B plus B plus 3B plus B. That adds up to 7B. So 7B equals 210. Divide by 7. We get B equals 30. So now we have the value of B. Well, we're looking for how many students study French only. So A we're looking for. We'll just plug that into the expression for A. A equals 2B minus 10, or 230 minus 10. 60 minus 10 is 50. And that's our answer. In summary, Venn diagrams can be helpful in problems with two overlapping sets. The problem may give a Venn diagram, but if it doesn't, one is often helpful for solving this kind of question. It's good to sketch it on the scrap paper. And remember to be careful interpreting wording. If it says all in X, like everyone in the band or everyone studying French or something like that, that always includes those who are also in the other group and includes all the overlap. But if it says all those in X only, all those studying French only, all those on the baseball team only, then that excludes the overlap group. We have to be very careful interpreting the wording. The double matrix method. In some more complicated set problems, every member of the population is classified in two ways at once. For example, if we were to look at employees at a particular company, we might group employees by gender, either male or female, and education. And here we're just going to consider two categories, a college degree only, that is a bachelor's degree, versus an advanced degree. In that example, every single employee would be classified by gender. Also, every single employee would be classified by education level. So everyone's going to be categorized in two ways at once. The information the problem could give might be how many females, and of course that would include both education levels, or it might be how many folks with advanced degrees, and of course that would include both males and females, or it might be something very specific, such as how many employees are females with advanced degrees. So the question could give us any of those pieces of information. It could also ask for any of those pieces of information. So there's a lot of information here. So let's start out by looking at this question. In a company of 300 employees, 120 are females. A total of 200 employees have advanced degrees and the rest have college degree only. If 80 employees are males with college degrees only, how many are females with advanced degrees? Well, we're not going to solve this just yet. Here's what I'm going to say. Notice that some pieces of information lead relatively quickly to other pieces of information. We know there are 300 employees, 120 are females, that means the other 180 have to be males. Similarly, if 200 of the employees have advanced degrees, well then there must be 100 with college degrees only. So there are certainly ways that some pieces of information lead to others, but we need a way to organize all this information. An excellent way to organize the information in such a problem is known as the double matrix method. This makes use of a matrix that is a rectangular array of boxes, each with a number in it. The columns will represent the categories of one variable and the rows will represent the categories of the other variable. For this problem, let's say that gender will be the columns and education level will be the rows. So here's the tricky part. There are two genders, so we will need three columns, one for female, one for male, and one for the totals, male plus females. There are also two education levels, so we will need three rows, one for college only, one for advanced degree only, and one for the totals. So the full system, here it is in symbolic form. We have, again, the columns are the genders, the rows are the education levels. A, B, C, and D are the raw data. So B would be the females with advanced degrees. C would be the males who have a college degree only. Those are the raw data. E and F are the row totals. We add across the rows to get everything on the right. So A plus C equals E. B plus D equals F. E would be the total number of people with a college degree only. So that would be males and females. F would be the total number of people with an advanced degree only. Again, that would be males plus females. G and H are the column totals, so we add down to get everything at the bottom. A plus B equals G. C plus D equals H. So G would be the total number of females. H would be the total number of males. In both those cases, we're just lumping everyone of all the degree levels together. Finally, T, that bottom right-hand box, is the grand total. That's everyone in the whole company, everyone in the collection. And we can get that either by adding across the bottom row, G plus H equals T, or we can add down the right column, E plus F equals T. And so everything should check, all those sums should be equal. So now, try this question again, and then we'll solve it with the double matrix method. You can pause the video here. Okay, so there are four numbers given in the question, and I'm going to write those in our double matrix. So now, as we said above, if there are 120 females, there have to be 180 males, so that they add up to 300. Similarly, if there are 200 with advanced degrees, there must be 100 with college degree onlys, again, so they add up to 300. Now look down the male row. We have 80 plus blank equals 180. So what has to go in that blank? Obviously 100. there must be 100 males with advanced degrees, so that 80 plus 100 equals 180. Well, now look across the advanced degree category. We have blank plus 100 equals 200, so clearly this has to be 100 also. There must be 100 females with advanced degrees. That's the answer for which we're looking. Let's just check and make sure that this works. We look down the female column, blank plus 100 should equal 120, so that would mean that this equals 20. Then we add across that top row, 20 plus 80 equals 100. Everything checks. And so, indeed, there are 100 females with advanced degrees in this company. If one of the variables has 3 categories, that would require 4 rows or 4 columns, because again we need 1 for each category as well as 1 for the total. Of course, the information can be given in simple numerical form as we had in the last problem, or in some other form, ratios or algebraic, something like that. There's many different ways that the numbers can be given. Here's a relatively challenging problem. So pause the video and then we'll talk about this. Okay, in a certain school there are 80 freshmen, 100 sophomores, and 220 upperclassmen, drawn from 3 cities. All right, so first of all, the 80, 100, and 220, those are the totals for different grades. We have grade level is one of our categories, so it has one of our variables that has 3 categories, and we have the totals in each of those 3 categories. Then we have 3 cities. That's going to be the other variable. What city is the student from? And we have 3 categories there. And here we're given percent information, 60% from A, 30% from B, the rest from C. And then we have some other piece of information. All the students from C are freshmen, half the students from B are upperclassmen, and the rest are split evenly between the other 2 grades. How many sophomores are from A? So for this, we need an enormous double matrix table. And here I've written in the totals for freshmen, sophomore, and upperclassmen, and I just went ahead and summed across that bottom row to get 400. So that's the total number of people at the school. So now we can start thinking about the percentage information. 60% of the students are from A. We need 60% of 400. Well, 10% of 400 is 40, so multiply that by 6, and that's 240. That's 60%. Then 30% are from B. Well, 30% is just half of 60%, so half of 240 is 120. 30 plus 60 is 90, so that means the last 10% are from C. So 10% of 400, of course, is just 40. So now we have all the row totals and column totals. Then we have this great piece of information. All the students from C are freshmen. So there are 40 students from C. All 40 of them are freshmen, and then we can just put zeros in these columns. So that enormously simplifies everything. Now we're told that half the students from B are upperclassmen, so half of 120 is 60. Half of them are upperclassmen, and the other 60 are split evenly, so 30 and 30. So now we want sophomores from A. We'll look down the sophomore column. We have blank plus 30 plus 0 equals 100. Clearly this number has to be 70, and that's our answer. The double matrix method can enormously simplify problems in which each member is placed into 2 different kinds of categories. The entries in the row sum to the row totals in the rightmost column. The entries in the column sum to the column totals in the bottom row. And the grand total in the lower right-hand box is everyone. This equals the sum of the row totals, and it also equals the sum of the column totals. Okay, back to Venn diagrams. For ordinary Venn diagrams that we covered in that earlier lesson, we considered populations with 2 overlapping groups. And that's a real simplification, because in real life there are many overlapping groups, so we certainly could increase the number of overlapping groups. The test loves to present situations in which members of the population can be placed in 3 overlapping sets. It almost never goes above 3, but it does like having 3 overlapping sets. So for example, at a high school we could look at the students who A, were studying Italian, B, were in the chorus, or C were on the baseball team. Those three don't have much to do with one another. They're really different skill sets entirely. So we'd expect that an individual student could be in all three of them, a student could be in none of them, or a student might be in any combination of them, any two of them, any one of them. So there are a bunch of different possibilities. In a way, we can think of this as three different questions. We could ask each student, are you in Italian? Are you studying Italian? Are you in the chorus? And are you on the baseball team? So three yes/no questions. Because there are three binary choices, the total number of possible scenarios is 2 to the third equals 8. We'll talk about this more when we get to the counting section, how we did this calculation. But right now I'll just show, if we imagine the yes/no answers we could give to those questions, we could have any of these 8 scenarios. And these would be in order the answers to those three questions. Do you study Italian? Do you sing in the chorus? And do you play baseball? A very good way to represent these 8 scenarios is with a 3-way Venn diagram. So much as a 2-way Venn diagram had 2 overlapping circles, a 3-way Venn diagram has 3 overlapping circles. And notice that here we have 8 regions, which are labeled with the letters A through F. So there are all kinds of regions. There are regions where it's in one circle alone, regions where just 2 circles overlap, and then there's the central region where 3 circles overlap, and of course there's H. Those would be the students that aren't in any of the 3 activities. So these are the 8 choices represented visually. Obviously, most of the information we might be given in the question concerns more than one region on that. And we saw a little bit of this earlier when we were talking about simpler Venn diagrams, that often what's stated in the question, the number given in the question is not an individual region, it's a sum of regions. So for example, if we're given information like the chorus has 120 members, or 40 students sing in both the chorus and the play, sing in the chorus and play baseball. So the chorus has 120 members. Well, the chorus, that's B, C, E, and F. It's those 4 regions all together. And sing in the chorus and play baseball, that's the overlap of the chorus and baseball team. That is C plus F. So the first piece of information gives us a sum of 4 regions. The second piece of information gives us a sum of 2 regions. And in fact, most of the information we're going to get is like that. Most of the realistic information we'll get in the question will be the sum of regions. One crucial region that is often given is the central region, the folks who do all 3. If the question tells us that some specific number in all 3, that is one region we definitely know. Because that central region is often given in the question, is unambiguous, and is included in most of the other common regions, it's usually good to start with one of these problems from the middle and work outward. In other words, start from that very central region. All right, so here is a question based on these scenarios. Pause the video and then we'll go through this question. Okay, there are a total of 400 students at a school, and this school offers a chorus, baseball, and Italian. This year, 120 students are in the chorus. All right, so that's the contents of one whole circle. 40 students are in both chorus and Italian. 45 students are in both chorus and baseball, and 15 students do all 3 activities. If 220 students are in either Italian or baseball, then how many students are in none of the 3 activities? So certainly the question is asking for the H region, the region outside of all 3 circles. So let's think about this. We're given T equals 400. That's our total. We're told that 120 students are in chorus. So that means the entire green circle, B plus C plus E plus F, has to equal 120. All those add up to 120. We're told that 40 students are in both chorus and Italian. So chorus and Italian, that would be B plus C. B plus C equals 40. 45 students are in both chorus and baseball. So chorus and baseball, that's C plus F. So C plus F equals 45. And 15 students do all 3. So that means that C, the central region, is 15. That's very important. And now we get this 220 are either in Italian or baseball. Well, Italian or baseball would be all the regions in either the yellow or the purple circle. So it would be A, B, C, D, F, and G. Those 6 groups together constitute Italian or baseball. And those add up to 220. So, let's think about this. If C equals 15 and B plus C equals 40, that means that B equals 25. And it also means that if C is 15 and C plus F is 45, then F must be 30. Well, now we know B, C, and F, and we can solve for E. So we have 25 plus 15 plus E plus 30 equals 120. We solve for E, we get E equals 50. Okay, let's put that aside a moment. Now, think about it this way. If we add all the people in Italian or baseball, so that's A plus B plus C plus D plus F plus G, so that's 220, and add E, which is an extra 50, well, that accounts for everyone in all 3 circles. So anyone who is in any of these activities or any combination of these activities, they add up to 220. So the only people not included in that group are the people in H, the people we're looking for. So H must be 400 minus everyone else, or 130 people. That's how many people are in none of these 3 groups. In populations in which each individual can be a member of any 3 categories, use a 3-way Venn diagram. Remember that many of the common categories will involve more than one section of the diagram, and work from the central region outward.